So here's a quick lesson on going over the definition of velocity. And for our sake, we're going to use the terms velocity and speed almost interchangeably. I say almost because there is a little bit of a distinction between the two. They both indicate how fast an object is going. Some of the units we might use to express velocity and speed would be miles per hour, meters per second. It could be inches per millisecond. It could be furlongs per fortnight. As long as it's some unit of distance divided by some unit of time, it's an appropriate unit for measuring speed or velocity, although we'll always end up converting into meters per second for just about all the problem solving that we do in this course. So if they're both measured in the same units, then what distinguishes the two? Well, velocity is what's known as a vector quantity, whereas speed is a scalar quantity. So a scalar quantity is anything whose measurement is expressed exclusively as some amount. Okay, so what are some examples? Time is a scalar quantity. Energy is a scalar quantity. Voltage is a scalar quantity. A vector quantity is fully described when you give an amount and have to specify a direction. So what are some examples of vector quantities aside from velocity? Force is a vector quantity. Electric field strength. We'll just say electric field. Momentum is a vector quantity. Okay, so it makes sense for me to say that I tied a rope around a big heavy block and I pulled it with a force of 500 newtons. Okay, so those are the units we use to measure force, newtons. We measure it in pounds in the English system, but newtons in the metric system. And as I pulled it with a force of 500 newtons to make it slide across the floor, it didn't quite have the same effect as the second time I pulled it with the same amount of force, because the second time I found a way to pull directly to the right, but at the first time I was pulling at an angle of 30 degrees above the horizon. So in the first example, the force is 500 newtons at an angle of 30 degrees, and in the second case, my force is 500 newtons at an angle of 0 degrees. So it makes sense to express an angle. The same is true for electric field, the same is true for momentum, and I'll put etc. There are several other examples of vector quantities. It would never make sense for me to say that I can hold my breath for 2 minutes at an angle of 30 degrees. Right? Once I said I can hold my breath for 2 minutes, I fully described the measurement of time by giving the amount, and it wouldn't make any sense to add direction. If you eat an entire package of Oreo cookies, you will have consumed, I'm making this number up, but perhaps you would consume 2,000 calories, northwest. No, of course it doesn't make sense for me to add the phrase northwest to the end of that, right? Energy is measured as an amount of calories, and there's no way we can associate a direction with it. So speed is described when you just say the number of meters per second the object is traveling with. But if you want to describe the velocity of an object, you have to say the number of meters per second and include the direction that it's traveling. So in your car, you probably have a speedometer, not a velocityometer, unless you happen to have a compass that sits right next to the speedometer on your dashboard. And then I guess in a way, you're being told the velocity of your vehicle. So let me give you another example to illustrate the difference between speed and velocity, or the difference between vectors and scalars. Let's say you walked 3 miles to the east. Here, let's make a north-south and an east-west axis. And you walk 3 miles to the east, and then you stop, take a little bit of a break, and then carry on and travel 4 miles to the north. And let's say that whole journey took 1 hour. Well, what's your average speed? All we have to do to find average speed, here I'm going to make a symbol for average speed. V, there's a couple ways I could do this. I could put V subscript AVG, average speed, or I could say V, and then if you just put a bar over the top of some variable, that's a way of implying average value of. So whichever one you prefer, right? In any case, these are just strictly equal to your change in position or distance traveled divided by the time it takes. Actually, let me just write the word distance here. We'll say that speed is distance traveled divided by time, whereas average velocity, now here's a difference in symbols. If I put V and then, this isn't just a bar I'm putting above it, it's a little arrow symbol. In your textbook, you might see that when quantities are written in bold, if you see something like a capital F versus an unbold capital F, this is a way of saying force as a vector, and this is a way of saying just the amount only of the force. So in that way, you're just giving the scalar quantity associated with that force. Well, because I don't want to switch back and forth between bold and narrow font, the other way to do it is to put everything in narrow font, but if you're describing both the magnitude and, oh, by the way, I'm not going to use the word amount anymore. Let's replace the word amount with the word magnitude. Okay, so when I give the magnitude only, I'm giving a scalar quantity, but if I give magnitude and direction, then I'm giving a vector quantity. So average speed, and don't confuse this symbol, which means average, with this symbol, which means vector quantity. Okay, average speed is distance divided by time. Average velocity is equal to displacement divided by time. So let's see what's the difference between the speed and the velocity in this example problem. So here the speed would be equal to a total of 7 miles divided by 1 hour. I think that's the way I said it, right? That when this person was walking, it took 1 hour to make the whole journey. So this math couldn't be any easier. 7 miles per hour. The velocity, on the other hand, the displacement is nothing more than taking your initial position and your final position and finding the shortest distance between the two. So the total distance traveled is in these two segments, but the shortest distance between the 2 points is itself a vector quantity. That represents delta x as a vector. And so you should be familiar with this special right triangle. If one of the legs is 3 and the other is 4, the hypotenuse is 5. So the distance traveled is 7 miles, but the displacement from the origin to the final landing point for this person is 5 miles. So the velocity is 5 miles in 1 hour. So it's 5 miles per hour, but wait a minute, that doesn't describe the velocity entirely. That's just a magnitude. I need to give a direction. Let's see. You've all heard the phrase SOHCAHTOA. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent of an angle is opposite over adjacent. So if I want to find this angle, I can divide the opposite by the adjacent side. So tangent of the angle I'm looking for is 4 over 3, which I believe comes out to be an angle of 53 degrees. So that's the way I would state this, that the velocity is 5 miles per hour at an angle of 53 degrees north of east. a magnitude and a direction describes velocity, a magnitude only describes speed.